Hi, this is Dr. E again, and welcome to Chemistry of Life video notes number 2. The title of this video is Properties of Elements Depend on the Structure of the Atom. If you recall, each element consists of only one type of atom, and every element has a different atom. Different elements have different properties based on the structure of its atom. So what is the structure of an atom? Well, atoms are composed of smaller parts called subatomic particles. The center of the atom is referred to as the nucleus. The nucleus makes up 99% of the mass of the atom. The nucleus contains two different kinds of subatomic particles. The first subatomic particle in the nucleus is called the protons. Protons are a single positive electrical charge. The other type of subatomic particle in the nucleus is the neutron. The neutron has a neutral charge. In other words, it has no charge at all. Protons and neutrons have nearly equal mass, and the mass can be measured in AMUs, which stands for atomic mass units, or Daltons. For example, a type of carbon atom has 6 protons and 6 neutrons. Thus, the mass of this carbon atom would be 12 AMUs, or 12 atomic mass units, or 12 Daltons. A third subatomic particle, called an electron, forms a cloud around the nucleus. Electrons have a single negative electrical charge. In a neutral atom, the number of electrons equals the number of protons. All atoms of the same element must have the same number of protons. Since the proton number is unique for each element, we refer to the number of protons as the atomic number. Thus, the atomic number identifies the element and tells us the number of protons. So, for example, if we say an element has the atomic number 7, we know that the element is nitrogen. If we say the atomic number of an element is 8, we know that element is oxygen. And if we say the atomic number of an element is 1, we know that element is hydrogen, because the atomic number is the number of protons, and the number of protons identifies the type of element. The atomic number is usually written as a subscript to the left of the symbol. If you're looking at the periodic table, the atomic number is on top of the symbol. In a neutral atom, by knowing the atomic number, we can determine the number of protons and the number of electrons. Because in a neutral atom, the number of electrons has to equal the number of protons. So in a neutral atom of nitrogen, with atomic number 7, we know that means it has 7 protons, but to be neutral, it has to have 7 electrons to balance it out, because protons, 7 of them, have 7 positive charges. So we need 7 negative charges to neutralize that. And so in a neutral atom, the number of electrons will always equal the number of protons. Right? The mass number is the sum of protons plus neutrons. The mass number is written as a superscript to the left of the symbol, or in the periodic table, it is the number below the symbol. By knowing the mass number and the atomic number, one can determine the number of neutrons in an atom. We do that by subtracting the atomic number from the mass number. Since the mass number equals the number of protons and neutrons, and the atomic number equals the number of protons, if we have a mass number of 14 and an atomic number of 7, that means we have 7 protons. And 7 plus what equals the mass number? Well, 7 plus 7 equals the mass number. So 7 protons plus 7 neutrons equals the mass number. They don't always have to be the same. You can have a mass number of 15 and an atomic number of 7. That would give you 7 protons and 8 neutrons. Okay. The mass number does not take into account the small mass of the electrons. That's why when you look at the periodic table, for example, if we're looking at helium, we see the number below the symbol as 4.0023. Well, the atomic mass, or the mass number, is actually 4. The 0.0023 is the mass of the electron. And when we include that, and we do 4.0023, that really is the atomic weight. What this tells us is that the electrons have very, very little mass, and most of the mass, again, is within the protons and the neutrons that are contained within the nucleus. All right, let's take a look at the concept of isotopes. Some atoms of the same element have different number of neutrons, and we sort of alluded to that already. These alternative forms of the same element are referred to as isotopes of an element. In nature, elements occur as a mixture of isotopes. And the unique or important fact about isotopes is that isotopes behave identically in chemical reactions if the isotopes are the same element. Some isotopes are considered unstable. The nucleus tends to break apart. We call this decay. As the nucleus breaks apart, particles are given off and radiation is released. These unstable isotopes are referred to as radioactive isotopes. Since living cells cannot distinguish radioactive isotopes from the non-radioactive atoms of the same element, they are both taken up by cells in exactly the same way. Since radioactivity is easily detected, radioactive isotopes can serve as useful traces, or one of my favorite terms, biological spies. What do we mean by that? Well, we could take a radioactive carbon and place it in a living system and see how that carbon moves and behaves inside that living system by following or tracing where the radioactivity goes. A great example of that was with photosynthesis. The formula for photosynthesis is carbon dioxide plus water yields glucose plus oxygen. Well, the question was, where did the oxygen come from? Did it come from the carbon dioxide, or did it come from the water? Well, they ran the experiment twice. One where the oxygen and the carbon dioxide had the radioactive oxygen, and the next time they ran the experiment, they ran it with the oxygen and water having the radioactive oxygen. Well, when they ran the experiment with the radioactive carbon dioxide oxygen, it was showing up in the glucose. When they ran the experiment with the radioactive oxygen in the water, it ended up in the oxygen. So they were able to trace where the oxygen was coming from. And they learned that the oxygen was coming from water and not the carbon dioxide. There's several other benefits of radioactive isotopes. Several radioactive isotopes are used in the treatment of cancer. They are also used in diagnosis. Some of you might have heard of bone scans, which use radioactive isotopes. They're also used in dating fossils. Some of you might have heard of radioactive carbon dating. They're also used in sterilizing food. So radioactive isotopes have several uses and benefits. However, radioactive isotopes can also be harmful to living cells because they damage cellular molecules. In particular, they damage DNA. All right, let's check for understanding. If an element has an atomic number of 5 and a mass number of 12, how many neutrons does that element have? Well, the answer should be 7, because 12 minus 5 equals 7, which gives us the number of neutrons. How many protons does this element have? Well, the answer should be 5, because the atomic number is the number of protons. How many electrons? Well, unless we're told otherwise, we assume this is a neutral atom, and the electrons should equal the number of protons in a neutral atom. So we have 5 electrons. What is the mass in AMUs? Well, the mass in AMUs is 12 AMUs, or if we wanted to say it in Daltons, we would say 12 Daltons, because we have 5 protons and 7 neutrons. 7 and 5 is 12. Plus, we were told that the mass number is 12. All right, a tricky one. Last one. If an element had 6 protons and -3 charge, how many protons and electrons would it have? I already told you it had 6 protons. I meant to say if an element had an atomic number of 6. Right? So if it had an atomic number of 6, it has 6 protons. But how many electrons does it have? Remember, it has a -3 charge. So that means it has 9 electrons, because it took 6 electrons to make it neutral. Then a 7th electron made it 1 negative charge, because you had 1 more electron than neutron. The 8th electron made you have 2 more electrons than protons, and the 9th one made you have 3 more electrons than protons, thus giving you 3 negative charge. All right, that is the end. Have a good night.